Grace and peace to you, and welcome back to my channel. This is Donald Siame, author of Hidden Mathematical Genius Within Revealed. Today, we'll look at vectors, and particularly position vectors. So what is a vector? According to physics, a vector is a quantity with both magnitude and direction. So a vector should have a size as well as direction. Okay, so now let's look at the questions. The magnitude of PQ is 20 units, given that OP is equal to 5,0 and OQ is equal to 17, y. What's the difference between a position vector and just a point? So a position vector is always written as a column matrix, while a point is written as a row matrix. So that is the difference. Okay, so here we have a magnitude, which is 20 units, and we want to find the value for y. So we are going to use the same idea we are using in a coordinate geometry. We know that magnitude is equal to, so here magnitude of PQ is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. Okay, so what you do, we need to have 2 points. Okay, so since we have PQ, we're supposed to have the point P and the point Q. So from the position vector OP, we can get the point P, which is just a row matrix. So this becomes 5,0, and the point Q will be 17, y. So from P, that's where we should get x1 and y1. Then from Q, we have x2 and y2. Then we can solve for y. Okay, so PQ, the magnitude PQ, we know that it's 20. So where there is PQ, you put a 20. So you have 20 is equal to square root of x1 is 5. So we have 5 minus x2 is 17. So 17 squared. Then plus y1 is 0 minus y2 is y. Again squared. So we have 20 is equal to the square root of 5 minus 17, you get minus 12. And minus 12 squared, you get 144. So we have 144 plus 0 minus y, you get minus y. And minus y squared, you get a y squared. So we have plus y squared. Now, I want to solve for y. So first thing, we need to get rid of the square root here. And we know that the opposite for square root is just squared. So we need to square both sides. So this side squared and this side squared. So 20 squared, you get 400 is equal to the square root and squared will cancel out. So we're going to have 144 plus y squared. Okay, so since we want to solve for y, the 144 here will come this side, and it will be 400 minus 144. So you get y squared is equal to 400 minus 144, you get 256. Okay, now we are not solving for y squared, but we are solving for y. So here, to get y, to cancel out the squared, we introduce square root. So we are going to square root both sides. So you square root this side and this side. So square root and squared will cancel out. So you get y is equal to the square root for 256. You get positive and negative 16. Now, according to the question, we need to find the positive value of y. So the positive value is just 16. So y is equal to 16. So that is question 1. We go to question 2. Question 2, we have given that OP is equal to 4,13 and the point Q is 16,8. Find the absolutes of PQ. So that is just the magnitude of PQ. So it's the same idea. We need to have the point P and the point Q. So the point P, we'll get it from the position vector OP. So as a point, it will be just 4,13. So we have 4,13. And the Q as a point, we already have 16,8. Okay, so that is x1, y1, x2, y2. Okay, so the magnitude PQ, or the absolutes of PQ, is equal to, we have the square root of x1 is 4, minus x2 is 16, then squared, plus y1 is 13, minus y2 is 8, then squared. Okay, so the magnitude of PQ is equal to 4 minus 16, you get minus 12, and minus 12 was squared, that is 144. So we have the square root of 144 plus 13 minus 8, you get 5, and 5 squared, you get 25. So we have 144 plus 25. So what is 144 plus 25? Yes, we get 169. So you have the absolute of PQ is equal to the square root of 169. And what is the square root of 169? Yes, we get 13. So the magnitude of PQ, or the absolute of PQ, is equal to 13 units. Okay, so this is how you perform calculations with regards to magnitude. Okay, thank you so much for your time.